Do you have virtual office hours?
I have not set up virtual office hours. I do have office hours where I'm actually in my office and I've had a student call in during that time. But I haven't set up another one. I was waiting for the online class to give me feedback about what would be a good time, and I've heard back from 1 of 30 about what would be a good time.
You may or may not know this, but do you know if the STEM lab is still operating in person or have they just shut down?
Say that again, if,
If the STEM lab
Oh.
is still operating in person or?
I have no idea.
Okay.
I think they might be.
They are?
I'm not sure, but I think I've heard of somewhere go to STEM lab.
I don't even know if the testing center's open. Is the testing center open?
I think it's just online, or I think the tutors could, I think it partially in person.
Okay.
Cause like some tutors.
It's probably just by appointment.
Yeah, they have the
Probably
option.
limit how many people are in there, yeah.
Because I sent them an email over summer to find out whether they were monitoring face-to-face or monitoring online. And I never got a response back and I didn't follow up, so.
The master set next
Thursday.
Thursday of next week.
Tuesday or Thursday?
Thursday. Tuesday, apparently there's no school. It's Labor Day, holiday.
I thought you said Labor Day was Monday.
It is, but I think
Monday, but I'm guessing that they just shut it down for.
we have 2 days off.
Let's do the 11th or
10th.
10th, yeah.
You're gonna force me to look at a calendar or something.
When is the
Man, do
second
those phones have calendars?
Yes, they do.
Oh, God,
I can even access the internet as long as I don't mind printing about this big. That was an exaggeration, it's actually smaller than that.
When is the second quiz? The second quiz?
Sorry,
The second quiz,
when is the second quiz?
yeah.
All right, so there was stuff written down over here before. And then I wrote it down on a piece of paper.
I think all we had was,
But
although it was written was the date for quiz one and the master set date.
All right.
in your syllabus, you say September 7, Monday, 9/7, Labor Day, and then appoint for the adult, and Tuesday, 9/8, faculty work day.
Oh, okay,
What that means?
so that means no classes.
Okay, faculty work day means no classes.
Right, okay. Now, does it mean I have to be here or not? I don't know. Pre-COVID, yes, that would mean I would have to be here. All right, so today, showing off my flip phone again. All right, so we have Thursday, that's right, 9, 10, master set 2, and then also labs. Tuesday, 9:15, chapter 2, 3 quiz. We'll throw them in together.
So for the chapter 2 and 3 quiz, would it just be like one question from each chapter?
I've gone back and forth. I've sometimes I'll do 1 from each chapter, and sometimes I'll just do 2 from each chapter, and it'll be 4 questions.
Okay.
Sometimes I combine it into 1 quiz grade, sometimes I combine it into, or uncombine it into 2 quiz grades. It depends upon my mood when I sit down. You want something more definitive before then?
Nope.
Okay. Any other questions at the moment?
So the last that we did last week are due this Thursday.
Yes.
And then whatever we do this Thursday, next Thursday.
Yes.
Okay.
The only time it would not be due the next Thursday is if we have that day off. So whatever we do the week before Thanksgiving will be due the week after Thanksgiving. And if we have a test on a Thursday, then you don't have a lab due that day, but whatever the following week is. All right, so I assume it is recording, and if not, then you'll just have your mixed rely on. All right, so let's take a look at, it's still one-dimensional motion. Take a look at non-constant acceleration. So by looking at this velocity time graph, what is the big clue that tells us that acceleration is not constant?
Graph is not linear.
All right, and I think that you were, with hand gestures, Kyle was indicating the same thing. So how do I find my acceleration time graph given my velocity time graph? All right, I don't have an equation here, so we have to do it the old-fashioned way of just sort of guesstimating. So first off, in how many places is acceleration equal to 0?
3, 4.
I got 4.
4.
Do I hear 5? Seems like people have settled upon 4.
In each inflection.
All right, so here, 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 and here. So sort of sketch that out. So I've sort of divided up into 5 regions now. In the first region, acceleration positive or negative?
Positive.
Okay, yeah, slope is positive. It starts out and gets less steep, so let's just sort of, something like that. In the next region, acceleration positive or negative? All right, and it looks like it's steepest somewhere, actually somewhere around there. Looks like that's the steep point right there. Obviously, it's a crude sketch. The next region,
Positive.
all right. Strange. It's oscillating back and forth between positive and negative. It doesn't always do that, as I'm sure you know. And then negative. And then what happens to my acceleration at the end?
It's positive still.
It is positive.
It slopes this, I don't know what I'm trying to say.
Yeah, it's almost like going to the infinite,
Yeah, so it's shooting off to some value. Don't know what it is. I don't think it quite curves back on itself, but it might. That's what I was looking at earlier, and I think it just edges ever so closely to vertical. This will kill you. So, when is the object speeding up?
From the first mark to the second one?
From here to here?
Yeah.
Mid-extreme. Not that far. Pardon?
Whenever the acceleration and the speed and the velocity is headed in the same direction, it's speeding up. Oh,
All right. So in this first region right here, they're both positive, so here it's speeding up. This next region right here, I guess, velocity is positive, acceleration is negative, it's slowing down. And also, I'm going from a higher speed to a lower speed. This is where the speed is 0. So the farther I get away from the axis, I'm speeding up in either direction. This next region right here, I'm speeding up. So you can look at it either as I'm getting farther from my axis there, horizontal axis, or my velocity and acceleration are both positive, or sorry, are both negative. And then slowing down again. I guess that matches up there because acceleration is positive, velocity is negative. Speeding up again. Make sure it's clear that there's a gap there. And then slows down again. And I can't draw straight lines. So what I'm hoping is that at some point you can look at a graph and be able to tell. I mean, yes, at this point you should all be, if I gave you an equation, as long as it's not something bizarre, you should be able to do the derivative of it. And probably it's bizarre stuff too, most of you could do at this point. But You should be able to look at a graph and be able to interpret it, because the big difference between math and physics is that we have physical meaning to all the stuff that we do. As one person said, physics is what gives math a purpose. Whereas a math teacher said, math is what makes physics fun. Now, what about displacement? How would we find displacement?
Derivate V. Derivate V. No, derivate, no, integrate.
Okay, integrate, or is there, I always use them interchangeably. Is there a difference?
As far as I know, no.
My engineer, there's a difference?
Yeah, I don't know.
Oh, okay. From an engineering physics point of view, there's no difference. From a math point of view, there probably is. All right, so in this first region here then, is my displacement becoming more positive or more negative? Just say from here to here. Okay. And so this is the slope of this graph. So it starts out with a low slope and then suddenly gets steeper. What about from this peak to here? Is my displacement getting bigger or smaller?
Small.
So the question
Well,
is,
if velocity is still positive, it would be still getting more positive, correct? But maybe at a slower rate.
and fight.
So it would kind of.
Is his argument, does his argument make sense, or is he missing something?
Isn't displacement how far away you are from the origin?
It's how far you are away from your starting point.
Okay. Well, you kind of get closer to that starting point if you're on the same line, right? No?
Oh, I did make a mistake here, but that should be starting here. Right.
Well, if velocity is still positive, it means that it's moving still away in the positive direction from the starting point.
Okay, yeah, and
So
that's,
if it decreases in velocity, that means that it's moving away from that starting point more slowly over time.
and that's the way to look at it. So by the time we get to here, we've gone in the positive direction. Another way of looking at it is, one thing an antiderivative or integral tells you is it's the area under the curve. Is this area positive? At any point, does that area become negative?
No.
So it is positive the entire time. I'm increasing as I go. I'm peaking at this point right here, but then it does start to level off. And it should be peaking at 0, because again, this is the slope of this graph. So when the velocity is 0, that means my displacement better be flatlining or leveling off. Now my velocity is in the negative direction. I've turned around. This is a turnaround point right here.
That should be negative displacement.
Okay? And so, as a really crude estimate, the question is, at what point is this area the negative of that area right there? You know, there's a certain amount of close enough on something like this, because I didn't give any numbers.
It's not.
Does that area right there look like the same as that?
Guessing it looks a little bit bigger.
A little bit bigger? All right, so we'll come in just a little bit. Sure, why not? Now my velocity is most negative at this point right here. So that is when this is the steepest. All right, so we peak at that point, we come down, we hit a, whoa. And then it eases off some. And then, so that point right there is what we're estimating is this point right here. A vertical marker board, that would have been really nice, Joe. So what happens at this point right here? What happens in terms of this graph?
So that's still very curve.
True, okay?
Does it start leveling off this way a little bit?
So it's doing that maneuver?
Well, no, not like all the way leveling off, but getting less and less steep
All right, and then what happens at this point?
at that point.
Okay, if it's steepest at this point, then it becomes less steep.
Does it start going like that towards the towards x-axis?
No.
Well, you don't have less net area under the curve, so does it just start going down again? It's just the slope that we're toggling?
All right, so it becomes a little less steep as I reach this hump right here, and then it becomes more steep again until I get to here, and then it becomes less steep. And very crudely, something like that. Notice also, what is it called when a graph goes from curving one way to curving the other way? That point when it switches.
Don't even remember.
Austin's out.
That's inflection.
And how do you find points of inflection in math class?
Don't you set those to zero? I think you gotta take like a derivative or something, and then set them equal to zero to solve for it.
That tells you the max and mins. How do you know when the point of inflection occurs? You didn't go far enough. Or I misheard.
You subtract that maximum.
Nope. That would be a really crude estimate, but not officially the way you would do it. Is there someone else who wanted to chime in?
Yeah, when the limit to the left and the limit to the right equals, because one should be negative and the other positive, approaching from the left and approaching to the right. And
Oh, as long as one's,
just in that point, they will be equal.
no, but the slopes, if you're looking at the slopes here, the slopes are both positive at that point.
Doesn't the slope have to equal 0?
No, slope is not zero.
No, it's this second derivative.
That's the key.
Right.
Yep, I only heard first derivative, Enrique. So second derivative. The point of inflection is when the second derivative equals 0. So we should have a point of inflection at that time, at that time, at that time, and at that time. So one more way of checking, they should all work together. So I can look at this purely from this point of view, or I can fine tune it by looking at my second derivative.
So acceleration at those points. Acceleration is 0 at those points too.
At the points of inflection here, right? That is just an absolutely horrible looking sketch there. I'm assuming in your own notes, it'll be drawn perfectly. So let's make up some numbers here. Oh, before we do the numbers, I did displacement versus time. Why did I not ask you to do position versus time? Or how would position versus time look different?
If you come back to, if it was up and down, you change completely your graph also, no?
It depends what you mean by change completely.
Because it will pass, it will be passing through, it will come to zero, then, you will have, let's say, up and down, passing to the same point, you have a displacement, but the position will go to zero when
Where?
it pass through the same point.
Oh, it's the pass through the same point as what?
When it started, I mean, if it goes up and comes down,
Not from what I'm hearing, what you're saying, because it sounds like, because at this point, we basically passed through the same point where where we started. That, what do we need to know in order to do position, or how would position look? Tell me about position first time.
Position might not actually end up rendering a usable, graph or function, because it can actually just loop back on itself, making, so like if I were to, figure out where a fly was flying around rather than its, displacement, I could show those loops, and, I assume it wouldn't really be usable.
You say it would not be a function?
Well, no, it could end up that way.
Except this is versus time, unless the fly is in two places at once, it would still, wherever it is, even if it's one-dimensional motion,
Okay, yeah.
it would still spread out over time. Now, if you've seen the movie The Fly, you know it's possible for the fly to be in two places at once, but we're gonna assume, just for the sake of this class, that that's science fiction. What's the relationship between displacement and position?
Position is just where you are relative to the starting point, whereas displacement is what that distance is at any given time. From your current position to the starting point.
How's that different from what you said for position?
Hmm?
It sounds like you defined it the same way twice.
No. Well, I might have, I don't know.
So position,
Position is, where you are compared to the starting point, and then displacement is, like your final minus up or the initial.
All right,
so position deals with the origin.
there we go. That's the word I wasn't hearing. I heard both of you say starting point.
And starting point deals with displacement.
Yes, starting point, displacement, origin, position. Think at Mercury. Ocean Pacific. Operations. Position deals with the origin. Master Po. Is that the one or Kung Fu? I can never remember. All right, anyway. Some say the sillier the memory trick, the more apt you are to remember it. So this is the change in position, which I believe was being hinted at there. This is my final position minus my initial position, or if we drop the subscripts, or drop the final one, we have some starting point, and then at some time t, we're at s. S of f makes it sound like there is a final position in this graph, basically going all over the place. So I have some function here. So delta s is equal to some function of time. So my position of where I am at some particular time minus, lost my vector symbol there, minus my initial position is equal to this function. So my position is just what that function that I have plotted right here, plus my initial position. So how would the position versus time graph look? Or give me a flavor of what it would look like. I'm not asking for a specific because there's still a missing piece of information.
Would it all be positive or no?
Not necessarily.
Is it like shifted?
Which way? or down, depending on SI. Yeah. The only difference between displacement and position is position could be potentially shifted up or down depending upon this piece of information right here. Therefore, what did I not tell you, thereby making it impossible really to do a position versus time graph? Yeah, I was thinking of something else.
The initial decision.
That's what I was going for. Yeah. Now, if you look at some of the old tests, I was a lot looser with displacement versus position. And so some of the early tests, like 2011, I might be using the word position when I meant displacement. I got that corrected. So I'm not as fast and loose with that anymore. All right, so I was promising numbers here. So let's say this displacement here, this is my origin, that would be 0. And let's make it meters. And at this point right here, negative 30 meters. Let's make this time 10 seconds, just so the math is doable. So this is 10 seconds here. We'll put a maximum velocity here of, again, don't know if this actually works, but we'll just pretend that it all meshes together. Let's make this maximum value here 20 meters per second. That minimum value, got that one, I got a couple peaks here. We'll make this negative 25, negative 20, negative 15. We'll make that 5 seconds. And that's probably enough information. So given my crude sketches here, so obviously everybody could do this. If everybody knows what they're doing, everybody could look at this and come up with an answer. There's a hard way to doing it where everyone would come up with a slightly different answer, and then there's an easier way of doing things where everyone gets the same answer. But what I want to know is, what is my average velocity? So let's start out at, we'll make that 5 there. How would you find average velocity?
Is it like displacement divided by change in time?
Absolutely. So if I want to find average velocity here, in essence, find the average of any function. So V average would be the integral of V dt from some initial time to some final time over the integral of dt from some initial time to some final time. The average of any function is the integral of the function over whatever the variable is divided by the integral of the variable. Well, that's just how much time there was, and this is the integral of v dt, or the antiderivative of velocity, which is just displacement. So the average velocity is displacement over time. I've given enough numbers here. What is my displacement over the whole trip?
Velocity times the time.
You're going more complicated than you need to.
Negative 30 meters.
Yeah, there we go. Is that what you said, Precious? Okay, didn't hear it. All right, so my final position, my final displacement is negative 30 meters. And so my average velocity, negative 30 meters, divided by, well, the way I've written it, 10 seconds, negative 3 meters per second. What's my average acceleration? Or how would you figure it out?
change in velocity over time.
Yep. So we start out at 5 meters per second, we end up at 0 meters per second, so what's my change in velocity?
-5 meters per second.
Over 10 seconds. Negative 0.5 meters per second squared. And I'm gonna make a quick note, this is an inspiration for test problem. That'll do. Okay.
Where do you get the -5 again?
Change is always final minus initial. So 0 minus 5. Or loss of total. I think loss of total. Okay. All right, questions? All right. Let's now make it more complicated. Call it chapter 4. So I gave an initial velocity and initial acceleration. After 3 seconds, what is the displacement? So first off, is acceleration constant?